So you might look for natural logs and inverse trig before you go into your substitution. It generally is going to be obvious if you're going to do an inverse trig. Natural log be a little bit more common. All right, well, let's start with the first one. So I want you guys to mostly do these. I'll help you, but I want you to to get through on how to do them, figure out what technique you're going to do, and then we can kind of do it together. All right, so number one, what's their technique and what are we going to do?
Substitution for
Good. Your substitution looks like the only really good option. Choosing u to be that, it will cancel with the x, so that's good. So let's do it on u. And then du. X. Solve for the x. Going back to integral 3x. And it's going to be u to the 1/3. Then we're going to replace dx with 1 over 4x u. Since we got x on the bottom and an x there, those cancel. We also are going to want to bring any numbers to the constants out that we can. So we got a 3 and a 4 that you cancel, but that's okay. We can bring that in front of the integral. Right, as 3/4 integral of u to the 1/3 du. That then is something pretty easy. We'll add and divide. So go ahead and do that quick little integration there. And don't forget the plus c. So you get 3/4 u to the 4/3. We need to plug u back in. And this will become 9/16. And then it's 2x squared 1 to the 4/3. And it's okay to leave it as a rational exponent because that's what the original problem was written as. Generally, rule of thumb is if it's written as a fraction exponent, rational exponent, you can leave it like that as your answer. If it's written in root form like that, then you should get the answer that way. And, it's a multiple choice test with one option, but that's generally how it works. Give the answer the same form that was given to you. All right. Okay, let's try the next one. Number 2. So, no way to really rewrite that, right? Not going to be a natural log. Not going to be long division is only when there's a fraction. Inverse trig is only when there's a fraction. So really, these last 3 are only options that get a fraction. So it's got to be a u substitution. That's really our only option, right? So it might not be immediately clear what's going to happen, but it should work. We just might have to do a little finagling. finagle it a little bit.
Expert math.
Yeah. I don't even know how do you spell finagle? Finagle.
Don't ask me to spell anything.
Finagle. Should be
Rule of
like,
thumb, never ask anyone in my program to spell anything because none of us can spell.
should be like in textbooks.
Yeah. Finagle it a little bit so it works.
Thanks, Professor.
So we're just gonna be the inside of the square root. Right, split the only option. But you're probably thinking, well, that's not gonna cancel the t because when you differentiate it, it's not gonna cancel the t, right?
Oh.
It doesn't necessarily mean you can't use a u substitution though. Still write it. Du just 2 dt. So then dt is 1/2 du. So again, we did not get a t to cancel. What do we do in this scenario?
Does it ever use small from first aid?
Yeah, got it. So in solving for t, well, let's go ahead and I'm just going to write it so in line here. So we still have t integral of square root of u, and then we got 1/2 du. And again, you can see we still have the t there, so we need to replace that. So if we go over here, t then is going to be, we subtract the 1 and divide by 2. So it's u minus 1 over 2. So now let's put that in. That the 1/2, let's pull in front. U minus 1 over 2. And I'm just going to go ahead and write this as u to the 1/2 power, just so it's a little better. Now, we still can't do it yet because it's still a product there. But we could still simplify this further. And if you notice, this 2 could actually come out in front too, right? This 1/2, because you can write this the same thing as 1/2 times u minus 1, right? So that could actually come in front as well. So in front of it, you end up with a 4th integral. And then this is just going to get distributed into those two. So u times u to the 1/2 would be u to the 3/2 minus u to the 1/2. Does that make sense? So now we can go ahead and integrate it. So add 1 and divide. There's 2/5 minus 2/3 Yeah.
This policy is going to be my downfall.
This has been a long unit. Eight section 9 with the review. How about you? Okay. Most of them are multiple choice. So
I like multiple choice. I got a 25% chance of guessing it right.
Huh? I mean, generally like at least 60% multiple choice. I looked at this one 2 days ago, but I can't remember exactly multiple choice.
I'm really good at guessing, so multiple choice is definitely good. I am literally the best guesser ever. It's also the worst, but it's the worst. Alex Vaughn.
So with something like that, you could obviously reduce that to 110. And if you needed to write this in root form, it'd be 110. Top is the power, bottom is the root. So square root of 2t plus 1 fifth minus 1/6 square root of 2t plus 1 third. Number 3, I'm just going to have you do that one on your own. Skip it for now. Because what are you going to do for number 3? Huh? No, you don't have to do that.
Just break it up.
Yeah, you can just break it into different parts. So you just make it 3x cubed over x squared, so it just becomes 3x minus 2 plus 9x. This is right it. Yeah. You only have to do long division if it was like an x plus something at the bottom. Like x plus 2 or... You can just do that one on your own. Also, number 4 you can do on your own. It's just a constant. So do these two. Alright. Number 5, take a look at that one. This one's not really fair. I don't think I would. If this one's on the test, then I would tell you what to do. This one, like I said, is not really a fair question. I don't think. Have any idea what you do with this one?
Not at all.
So one through the list. No way that you can rewrite it. There's no. It's not a natural log. Long division, you can't do that.
Substitution for x squared. Looks like I'm not.
Do a U substitution. What would you substitute for U? X squared. Yeah. The only problem is it would be on this both on the bottom.
No.
It wouldn't cancel it. This one, you actually, I think I'm actually just going to throw this one out. I'll tell you what it is. This is actually an inverse tangent. It's an inverse tangent. In order to do this, you actually have to rewrite it like this. So you pull the 3 in front, but again, I'm not gonna have you do this one. If it is on the test, then I'll make a bonus or something. Because I don't foresee this actually ever being on the AP test. But anyhow, you're gonna pull the 3 in front, so we'll write it as 1. And then you actually have to write the bottom as like something squared plus something squared, like our. Let me show back to you. Our inverse tan. I'll show you real quick. All right, so here's our inverse tan. Our tan. We want the u squared, and then it's a constant squared plus whatever the u is squared. The u can be a function, whereas a is just a constant. So what we're trying to do here So. Alright. Is do something squared, some constant squared, plus some function squared, or u. Like that. The only way to do that is to factor that bottom somehow. Yeah. But in order to factor this, do you guys remember, do you ever done completing the square?
Sounds familiar, but I don't remember what how to do it.
So you need to write this as like x minus something squared. Okay. So what we'd be looking for is x minus 3 squared. The only problem, that doesn't exactly work because, well, in order for that to work, it'd have to be plus 9 instead of plus 18. See that? So basically what we're left with is, to complete this square, we've got to add some extra number, like add or subtract or counteract that. Do you remember how to do that at all? So basically we write it like this, x squared minus 6x, and then we need it to say plus 9 for it to work. In order for this to work, that needs to say plus 9, but it doesn't. So we group it like this, we still got the plus 18. In order to counteract that, we subtract 9 on the outside. So that we've added 9 here, we've subtracted 9 here. Vaguely familiar, maybe. So we're basically coming up with this number because it's this number, half of this one squared. And then to counteract that, we got to subtract 9 on the outside. So that we're adding 0.
I remember doing that, but I never,
No, so it sounds familiar, but I don't remember that at all.
This then becomes x minus 3 squared plus 9. Okay. At least maybe see how I got there. So now we have a function squared and a number squared. We then would write this, if you track down here, we'll make this our a, so this is going to be where the 9 is. It becomes 3 squared, and then this is x minus 3 squared. So we've rewritten that problem as 1 over 3 squared plus x minus 3 squared.
I see why it's not there. That's a whole lot.
Yeah.
I feel like even when you tell us that it is.
Right, and that's why I don't think it's a very fair question. So, again, I'll double check the test, but if that is on there, that's how you come up with this, and I'll make it a bonus question. So then, the way that you check this, the inverse tan is u prime over a squared plus u squared. So then this is the a, right, and this is the u. You just need to double check that the derivative of this inside is the top, which it is. The derivative of x minus 3 is just 1. So the way this then works is it's the arc, 3 times the arc tan. And then if, I believe it's u over a. X minus 3. Thing. Anybody have that page turned up? So that's the answer, plus C. So I guess you could add that to the list, but I'm not going to hold you accountable for knowing how to do that. So inverse trig, and then with an addition to that, complete the square. And then do inverse trig.
It's actually,
I think there's a couple problems in that section on that, but we didn't do them. That's how you do it. But again, to me, like for you to be able to see that, it's a little bit unfair.
This is what you assignment for that one? There's only one question that says, "Can think about the method of last resort," and I don't like that. So I'm just
Okay, this must be the method of last resort, yeah. But that's gotta be it. You had that one question on it. The method of last resort. Complete the square, then do an inverse trade. I guess so.
But the problem itself looks nasty.
It seems like you have to leave the number in the
Right, I know.
Which I'm not, so.
What page is that on?
158. It's like a cube root in the bottom. I don't know if it's this exactly.
Huh.
Something like it.
Think about the method of last resort.
If you gave me that one,
How's
I would
that?
not have done it.
Well, that's something that was discussed in the
No.
notes.
I just looked and I didn't see it.
That's great.
Alright. This guy had fun writing the textbook, I think.
Yeah.
Alright, let's see a couple other ones that you guys could do here. Alright, number 6. Just playing a few for you guys to try tonight here. So number 6, what does it look like you want to use here? It could be a natural log. Yeah. So it will end up being a natural log. It's actually a natural log and a U substitution kind of put together. Okay. But you could probably figure out that it's just a natural log. You can see that this does differentiate to the exact, right? Yeah. So it actually is just a natural log. If you didn't immediately see that, you could do this as a U, and then the sine would cancel the cosine, and you're left with just 1 over U, which is then natural log of U. Yeah. So,
Substitution.
okay, and U substitution will work. So this is a natural log. Either way, you're going to get natural log of the answer, because if you do a U substitution, it's going to be the integral of 1 over U du, and then you'll know that's a natural log.
Yeah,
and then
that
you'll
one I
just work
definitely
it.
know, but just looking at that.
Yeah, if you can recognize that that's just a natural log, you can definitely skip the U part. But you can do the U if you want to. Good. All right. How about number 7?
So that would just be natural log of y.
Natural log of sine y minus 2.
Oh yeah.
Yeah. So this answer. So if you think of the derivative of this would be 1 over sine of y minus 2 times the derivative of that, which would be just cosine of y. Number 7, what do we use here? So treat this as 2 separate integrals of a plus sign, do this part separately and this part. You should think there's a derivative of something that gives you secant tan. Derivative of what is secant? Yeah, secant, right. So if you choose this to be your u, you'll then just have secant u tan u plus secant u tan u. And then so that's just secant. So you want to u be theta minus 1. And just treat that theta squared separately. And then you guys can let me try number 8. I'll let you see if you can figure out that one. So ones you need to do are 3, 4, 6, 7, 8. And number 8 looks like what you think. Oh yeah. They should start to stick out more the more they're doing.